Today, we're going to crack open Cancer's survival playbook. We're going to look at the incredibly clever strategies it uses to survive, to thrive, and to resist pretty much everything we throw at it. So, let's dive in.
This is the question that just keeps everyone up at night. Patients, doctors, you name it. A treatment works. The tumor shrinks. The scans look clear. And then, boom. Months or even years later, it's back. Now, this isn't just a case of bad luck. It's proof of how incredibly resilient cancer is. So if we ever hope to beat it for good, we've got to understand its game plan. We have to figure out how it fights back.
All right, first tactic in the playbook, the energy heist. You got to think of it like this. For cancer to grow so wildly out of control, it needs a ton of energy and raw materials. I mean, a colossal amount. But here's the thing. Cancer doesn't play by the same rules as our normal, healthy cells.
Just think about it for a second. A normal cell, it divides in a really controlled, orderly fashion. But a cancer cell, its one and only job is to make more of itself, as fast as it possibly can. And that relentless, nonstop division creates this bottomless pit of a demand for fuel. So how does it get it? Well, it meets that demand by completely rewiring its own internal engine. So this is where you can see cancer's big strategic choice. Normal cells, they're really efficient. They kind of sip their energy from glucose. Cancer cells, nope. They choose to just gulp it down, using a process that's super fast, but honestly really wasteful. So why would it do that? Well, for cancer, speed is everything. And this super fast consumption isn't just for energy, it's also cranking out all the raw building blocks it needs to build new cancer cells at a terrifying pace.
So this whole metabolic switch has a name. It's called the Warburg effect. And it's a really key feature of so many cancers. They basically become total sugar addicts, choosing speed over efficiency every single time. And this is so fundamental, we actually use it against them in medicine. You've probably heard of a PET scan, right? Well, that's exactly how it works. It looks for these hot spots in the body where cells are just gobbling up huge amounts of sugar. And that tells doctors right where the tumors are.
Okay, so that's how cancer fuels its growth. But what about when we attack it directly? Well, that brings us to its next trick, being the great escape artist. If the energy heist is about growth, this is all about survival. When we hit it with something like chemotherapy, it doesn't just take the punch. Oh no, it actively starts evolving its own defenses. And it's not just one defense. Cancer cells have this entire toolkit of resistance mechanisms. We're going to break down 3 of the most common and frankly most effective ones. Think of it as building pumps, calling in repair crews, and just straight up ignoring the self-destruct button. All right, first up, they basically build their own bouncers. See, a lot of chemo drugs have to get inside the cell to do their job. So what do the cancer cells do? Some of them start pumping out these tiny proteins. One is called P-glycoprotein, and you can literally think of them as microscopic bouncers at a nightclub door. They just grab the chemo drug molecules and physically throw them back outside before they can cause any trouble. Next, they bring in elite repair crews. Many types of chemotherapy, a common one is called cisplatin, work by shredding a cancer cell's DNA. They damage it so badly that the cell can't divide anymore. But what's the cancer's response? The resistant cells just supercharge their own DNA repair systems. They start churning out these special enzymes that act like a super fast repair team, finding the DNA damage and fixing it almost as quickly as the drug can cause it. It's wild.
And this last one, it's maybe the most defiant move of all. They just learn to ignore the self-destruct signal. You see, our healthy cells have this built-in safety program called apoptosis. When a cell gets too damaged, a master gene called TP53 basically tells it, all right, time to self-destruct for the good of the body. But what do many cancers do? They just break that gene. They delete it, they mutate it, and once that self-destruct button is broken, they can take a massive amount of damage from chemo and just keep on going.
Okay, so this brings us to the final, and I think the most insidious tactic in the entire playbook. This is the one that explains that heartbreaking question from the beginning, why a tumor can look like it's completely gone and then just roar back to life. And the answer lies with a small group of hidden operatives, the sleeper agents.
For decades, our main strategy for fighting cancer has been to go after the thing that makes it so different, its rapid growth. Chemotherapy, at its core, is a poison designed to kill cells that are dividing really, really fast. But this entire approach has one major critical flaw. And the flaw is this. What if the most dangerous cells in the entire tumor aren't the ones dividing fast? What if the true masterminds, the ones that can regrow the entire tumor from scratch, are actually just lying dormant, dividing super slowly, and basically just waiting for the chemo storm to pass them by?
Well, those cells are real. They're called cancer stem cells, or CSCs for short, and you can think of them as the queen bees of the tumor. They only make up a tiny, tiny fraction of the tumor's total size, but they have two absolutely terrifying abilities. One, they can make endless copies of themselves, and two, they can create all the other worker cancer cells that make up the bulk of the tumor we see on a scan.
And this right here, this gets right to the heart of the problem. We can come in with our best treatments and kill 99.9% of a tumor, wiping out all those worker cells. But if we leave behind even a few of those cancer stem cells, that tiny population has the power to regrow the entire thing. And a lot of the time, it comes back even more aggressive and more resistant than before.
So how do they survive the onslaught? Well, does this list look a little familiar? It should. They use the exact same tactics we were just talking about. Because they're often dormant or slow dividing, chemotherapy that's designed for fast-growing cells just sails right by them. And on top of that, they come armed to the teeth with those drug-pumping bouncers and those elite DNA repair crews. They are, without a doubt, the ultimate survivors.
Okay, so yeah, it's a pretty formidable enemy. That playbook is tough. But here's the good news. Understanding the playbook is the first step to writing our own. And by learning cancer strategies, scientists are now developing some really powerful new counterplays.
The whole way we think about treating cancer is shifting. The goal isn't just about brute force anymore, just killing everything that grows fast. Now it's all about precision. It's about identifying and targeting the specific survival tactics that make these cancer cells so tough to kill for good.
And this new approach is all about direct counterplays. So for every play cancer has, we're designing a counterplay. To stop that high-speed fuel heist, we're working on metabolic inhibitors to basically starve the cancer cells. To block those escape hatches, we're designing drugs that can jam up their molecular pumps. And to take out those hidden queen cells, we are finally developing therapies that can specifically find and destroy those cancer stem cells.
When you really boil it down, cancer isn't just a disease of uncontrolled growth. It's a disease of evolution. It is constantly adapting to survive whatever we throw at it. The fight against it has literally become an evolutionary arms race. But by finally understanding its playbook, by seeing its strategies so clearly, we are, for the first time, learning how to get one step ahead. The big question now is, can we learn to out-evolve